working you guys with some of the word problems that are all throughout this section. Now, I like to wait on a lot of the word problems in quadratics because when they give you some of the word problems in each one of the sections, they're kind of hoping that you would complete the square with one thing or use a quadratic formula with another or something along those lines. What I'm trying to show you guys is that you don't really need to work with a specific style. A lot of times you can get all the information you need to know if you know what to look for in the calculator. So we're going to spend time today, how do you use the calculator for word problems? It's pretty easy. I want you guys just to kind of pick up on some of the trick stuff. Now granted, there are going to be calculator, non-calculator parts of tests and stuff. There'll be some things I'll let you use it for, some things I won't, but we'll worry about that later. Don't forget, the test is still Friday. So here we go. We have a rectangular stained glass window that is 2 feet by 4 feet. I have 7 square feet of clear glass to create a border of uniform width around the window. What should the width of the border be? So we want to figure out how in the world is this going to go. We start by draw a picture here. Shut up. No, really, you guys talk way too much. Okay. We start with a picture. It's 2 foot by 4 foot. And the trick here is that it says that it wants to create a border of uniform width all the way around it. So I'm just going to create a border. And call this distance x. That's the same value all the way around. Okay? Now if you look at it, what's my new length and width? It's
2 plus 4 plus.
yeah, 2 plus 2x. So my new length and width would be 2 plus 2x and 4 plus 4x. Oh, sorry, 2x, excuse me. Everybody see why that is? I'm adding x on the top and the bottom. What's x plus x? 2x. There you go. Going from here to there. 1, 2. That's all. Okay. So you want to set it up something like that. Think about what they're giving you. They're telling you that you have an area of a border. You have 7 square feet to work with. The area of the actual function itself, the actual whole picture and frame, would be 2 plus 2x times 4 plus 2x. And you have to subtract out what's in the middle. 2 by 4. Subtract out the 8. This is a very basic, believe it or not, this is kind of like a basic calculus problem. This is an optimization problem. You want to maximize the value of the largest width that you can get with a specific function. It's called optimization. What happens here is that you only have a couple of steps of algebra. FOIL out. We get 8 plus 4x plus 8x, so I get 12x in the middle, plus 4x squared minus 8. Are you okay with that? Yeah. I thought I was losing. Why am I what? Awesome? Yes.
No, that wasn't my question. Okay.
Should be.
I got it.
Combine like terms and remove that 7 or so I set aside equal to 0. I get 0 equals 4x squared plus 12x minus 7. Okay? Now I'm back to a quadratic. Let me show you how you can find information out of this on your calculator. Take your calculator out, and let's put this in the calculator. So it's what our y equals.
Oh, but then I can figure everything else
Let's go to our y equals table.
out.
And I want to substitute in the equation I have. 4x squared plus 12x minus 7. And hit graph. I get some sort of a graph. Are you okay with that? Now, what this graph is doing is we don't see the very bottom of the vertex. But does that matter to me? No, because what it's looking for is I'm looking for the zeros here. If you look at the curve, if you look at this curve, this graph crosses graph, yeah. I said graph. Some value that's negative and some value that's positive. Which one of those would give you a positive result for width? A positive one. Which means we need to find that zero. There's a button on your calculator that does that. Yes, sir?
I was gonna say I found it.
Well, yeah. What I want to do is, I think yesterday we talked a little bit about this. Hit second, calculate. The second option there is 0. Okay. Don't use the trace function. The trace function doesn't always work. It's not always right. This actually does the work correctly. Now this is where we are having problems about, I know in third hour we were having some issues about trying to decide what does that mean be a left boundary. Oh, whatever. Yeah, it's a number. Yeah, it's close enough. So what I'm looking at here is if I don't want to worry about this value here, because this is going to be some negative number. I don't know what it is. I don't know negative 3. But over here, it's some positive value. And the reason why I'm only looking for the positive value is because I cannot have negative length. It doesn't work. So the left boundary, as I'm looking at this side of the curve, would be below the graph. The right boundary would be above the graph. Yes, sir?
If the calculate the 0, can't get on the 0.
What's that? You won't get on the 0.
So why?
Here's why. Because it's moving just incrementally. It's jumping over, correct? It's jumping over but between like 4.45 and then it jumps over to 0.6. That's okay. Because what I want you to do is everybody see how it's jumping between the negative value of y and then all of a sudden y becomes positive? Somewhere between there we hit 0. So that's what I'm going to select. My left boundary will be when it's negative. My right boundary will be when it was positive. And then it's going to ask you to guess. Yellow. Nope, it's at 0.5. So how wide should I make the border in uniform length around my picture frame? Half an inch. That's it. Calculator will allow you to find those zeros to find that kind of information. Okay? There's a lot of stuff this thing's going to be able to do for us. Okay? A lot of stuff. Let's try another one.
How does like 0.5 go into the equation though?
What happens here is that this value is some negative number. I don't.
Well, like, what's the answer? 0.5?
Mhm. What should the width of the border be? Half an inch. 0.5 inch. That's what that means. Because you only have 7 inches of glass total area left to work with. So I use that border going all the way around. I'll use up all of it. That's all it was. With what, the calculator? Or? Okay. The setup. Start over on the setup. Okay. 1 second. Setup. you start with a picture. Picture is 2 by 4. You want to put a frame around it that has uniform width. All that means it's getting the same width all the way around. Call it X. Why so many? That way you know that it's the same amount going all the way around. Okay. So my new width going across would be 2 plus 2 x's. X plus 2 plus x. Because I added this much on both sides.
Would that be X squared?
What's x plus x? Same deal, going the height wise. So you wind up with the new picture frame area would be 2 plus 2x times 4 plus 2x. What we were looking to find was to figure out what this area, since I have 7 square feet of glass to work with, what should be the dimensions of that value of x? So it's the same value all the way around. Okay? So if I know that I only have this much stuff to work with, that means that total area has to equal, oops. I do it all at once. That's what I get for trying to move things around. That whole area was 7. That has to equal the big picture, subtract the big picture including its frame, subtract out the picture. That had an area of 8. That's all. So then when I foiled it, we had 8 plus 4x plus 8x, so I just wrote 12x, plus 4x squared minus 8. I wanted to set that other side equal to 0 so that way I can factor and or use my calculator to get the zeros. So we have 0 wound up being 4x squared plus 12x minus 7. Now if you wanted to go the long way and factor it, what times what's negative 28 you add together to get positive 12? 14 and 2.
14 and 2.
Excellent. So I use 14 and 2. I'll show you this way too. If I use 14 and 2, I get 4x squared plus 2x. Minus 2x plus 14x minus 7. If I group that, take out the 7. The two possible solutions that I can have for the value of x, which is the width of the border, would be negative 7/2, which I can't do, or 1/2. What I was doing there was showing you guys how to throw it in a calculator and calculate a 0. It's just a little bit quicker, so you don't have to do that factor. Yeah.
How do you know if you're being negative?
If it makes sense. Can you have a negative width?
No.
That's why you can't have it.
Okay.
That's all it is. Seriously, that's really all it is. You were going to say, what were you going to say then? Okay, good conversation. Yes?
What did you want to actually put in the equation?
Second, calculate. Second, calculate. Option number 2 is the 0. You can either press 2 or you can just scroll down and hit 2. Remember that left boundary, you read this going from left to right. So you're looking at, well, I want to figure out the 0 at this part here because it's the positive one. So that means as I'm going from left to right, I have to be below the curve, below the axis, and then I got to be above the axis for the right. So we just hit enter, then move above it, hit enter one more time, and it gives you your 0. It's just as fast going that way as it is to factor, but sometimes when you have really weird values, using the calculator can make your life so much easier. Okay? Sound a little bit better? All right. Obviously, open the door, the light goes on. Okay. let's look at, when was it? Let's look at the shoe one. Yeah, I gave you that because these are the problems you're going to do for homework, but I'm doing a couple examples off of this over the course of the next couple of days. Okay? Yeah. Yeah, we're going to do a little bit of the review stuff. Bless you. So, when I'm looking at this one here, this is a very common cost problem. Your cost benefit problem is very similar to, have you guys ever played the game Lemonade Stand?
Yes.
Go ahead.
Or, yeah, there's crack dealer, I think that's a version of it too.
Did you say crack dealer?
Yeah, I did. Yes. So you sell, how do you maximize your profits? How can you get the most money? At what cost would you have to sell it at? Yeah, well, you get the idea. So what happens here is that if you're a shoe store and you're selling 200 pairs of basketball shoes each month when they're $60 a pair, for every $1 you increase in price, about 2 fewer pairs of shoes will be sold. So somewhere in that balancing act of sales of what is the most I can sell something for that people will still want to buy it, there's going to be a maximum value that I can, a maximum revenue that I'll be able to incur, I should say. So here's what happens. When you see a problem like this, there's 2 things that are happening. You have sales, and you have price. So you have 2 things working with each other. And we're going to turn it into a quadratic. How many shoes did I sell initially? 200. At what price? 60. Now, for each $1 increment in price, if I add $1 to the price, I'm throwing the value of X in there because if I wanted to add $3, it'd be 3 would be my value of X. So then my new sales price would be 63. So I'm going with that? So if it was, bless you, if it was adding up 2, I would be 60 plus 2X. Is that for each $2 an increase, for each $5 an increase? It could be 2X, 5X, whatever. All right? But if I'm adding $1 there, or adding an increase, what's happening to my sales? Minus 2X, very good. I get minus 2X. So I'm getting some quadratic here. Now, what I want you guys to see is that there are multiple things that you can do here. This is written up in what form? Standard, vertex, or intercept? Intercept. Intercept.
Yay!
It's written in intercept form, which means you can find zeros. Or you can graph. So let me put this on another sheet here to show you what we can do. If I go right to my y equals in the calculator, and I type it in exactly the way I see it, without foiling it out at all, there's no reason to. The calculator will know what to do. Y equals, it's out of the way. I have to do parentheses, 200 minus 2x, 60 plus x. I'm going to hit graph, because I want you guys to see what the graph looks like.
Nothing happens.
Yes.
Oh, did I?
Probably because it's on a scale of 10s.
No, it should still graph out.
I have 2 vertical lines.
I have this.
Oh, why is that? Okay. Now, what I want you guys to notice is you're right. You can't see anything. So take a look at your table. First of all, if I'm looking at this without foiling it, is this going to be up like a cup or down like a frown?
Definitely.
Up like a cup.
Down like
It's down like a frown because what's your a squared term?
Oh,
It's negative. Okay, foil it out. You'd have, so I know it's going to be. I know it's going to do this somewhere. I know it's going to be some sort of. Okay. This point right here, if it's down like a frown, that would be its vertex. Do you agree? It's also what of that function?
You know what?
The axis of symmetry would be the x coordinate, but I heard some. Did you say it? What is it? It's the maximum.
Oh.
It's the maximum value. It's the highest point of the curve before it goes back down. Whereas if it was going like this curve where it's up like a cup, what would this point be? The lowest would be the minimum. Okay. Now in the calculator, there's an option to solve for the maximum or minimum. But before we do that, we need to kind of figure out where it's going to be so we can play around with it on the calculator. Yeah, your window's all messed up. So take a look at your table. And it's kind of tough to see it on mine here. If you scroll up to around 20-ish, you'll notice, sorry, I'm just trying to get this so you can see it. Notice when you get to about 20, it's increasing, gets to 20, then it starts decreasing. That meant it got all the way up, and it's on its way back down. So what I want to do is change my window around so I can actually calculate at what value in here did the maximum really occur at. Did it really occur at 20 or did it occur somewhere else? Yes, ma'am? Yeah, but use the other one because that one doesn't have the, shouldn't be broken because that's mine.
I didn't break it, so I grabbed it all here.
Well, it's nothing wrong. The window's just messed up.
What's the window?
Just bring it over there and change the window. What I want you to see though,
She just said that's the problem.
we're going to change the window right now. Will this 20 value be the vertex?
No. Yes.
Yes,
Yeah.
Why is it yes?
because it's symmetrical on both sides.
Exactly. The reason that it's going to be the
Holy
what do you-
poop.
what do you call it? The vertex. Notice you have symmetric twins. See how at 19, 12, 7, 98, 21, 12, 7, 98, 18, 12, 7, 92, 22, 12, 7, 92. They're symmetrical about that value. Therefore, the 20 is the x coordinate of the vertex, which means at this point, it's 20, comma, what was the y coordinate, guys? 12,800?
12,800.
Okay. So they're telling me that if I increase my price $20, I will maximize my revenue at 12,800. So what would I have to sell my shoes for? $80. So the calculator is going to help you figure out what this value of X, whether it's a maximum or a minimum. But then you have to take it in context. What does that actually allow me to do? Well, it's telling me that, excuse me, if I sell my stuff for $80, I will make a maximum profit. It might not be profit, but I'll make a maximum sales. That's too many zeros. That's a whole lot of shoes. Okay? The calculator is allowing me to do that by understanding what a maximum is, what a minimum is, what zeros are in relationship to a problem, things like that. Knowing what parabolas are. Parabolas are symmetrical about a specific value. Okay? Let's try another one with the calculator. The one right below it. Let's talk about the Big Bertha cannon from World War I. Big Bertha, I believe, was a German cannon.
Yeah.
Oh, was it?
And
Oh, that thing was spooky.
This cannon,
Can I draw a cannon? What? Jonas, just stop talking.
so there's a cannon. What was the initial height of the cannon? Take a look at the function they're giving you. Think about it. Think about what they're giving you here. They're giving you this equation. Y equals negative 0.0196x squared plus 1.37x. And that's it. Where is this cannon starting at? Zero. So what's the height of the cannon? 0. Okay, I know it's kind of roughly ideaed here. Normally, if you think about it, if you're throwing an object, JC, I'm throwing an object. It went up and down, right?
Yeah.
Kind of a parabola. I'm starting my throw here at about, we'll say about 6 feet off the ground, right? So my initial height would be at 6 feet. Here, it's just saying that you're starting at the ground. It's shooting up from 0. That's all. It's okay. Technically, the cannon. This is the same thing we talked about earlier. Yes, sir.
What would it be counting, like, in your case, the 6 feet, that would be the start of the 0?
Yeah. Because you have, and there's problems like that built in this set that we'll probably talk about more tomorrow about how you deal with initial velocity style problems with heights thrown in. And they're really easy to work with. It's really simple. It's just a matter of drawing a picture. You guys did this last year with angles of elevation and stuff like that in geometry when you had the golfer and the tee box hitting up over. You had a certain height off the ground. You've done these problems.
I remember doing the firework one.
Yeah, it's the same idea. It's the same idea, but instead of being a linear straight up looking at it, an angle of elevation problem, find that linear height, that line height, we're working with a curve. That's it. Yes, sir. Anyway, yeah, back to this one. So what's happening, he's underground, and he's shooting up,
He's in a trench.
and he's landing out here and exploding and going boom, boom. Okay? So what happens here is that this problem, yes, there's no +1, +2, +3. The initial height of the problem is at 0. If you use 0 for x, what do you get for y? 0. So that just means that there's nothing, the y-intercept is at 0, so it means it's starting at 0. If it was +1, that means it was 1 foot off the ground. If it's at +4, it's 4 feet off the ground.
Oh, because there's no plus.
Correct. Okay. So what happens halfway here?
It reaches maximum.
It reaches its maximum. It reaches its maximum at its axis of symmetry, right? So one way to figure out where the maximum is occurring is to find the axis of symmetry. Can I still do that with really crummy decimals?
Yeah.
Sure, let's do that. Axis of symmetry is the opposite of b over 2a. Well, in this case, it's negative 1.37 divided by 2 times negative 0.0196. And I'm still going to get crummy decimal. But the calculator does that for me. Use your alpha y equals option to create a fraction bar. You will be less likely to screw up. Trust me, I know. And I think you should get, if you do that, you guys should be getting around, what, 34 and change, about 35? If you, it was like 34.96?
Not 34.
Okay. So can we, just for argument's sake, we say that's right, oh sorry, JC. We say that it's about 35 feet, or 35? That's my x value. This horizontal distance going out this way, starting at 0, is 35. That's miles, in miles. What's the vertical height there? What would you do to find the vertical height? What do you get? What was it? 23.9 or something, right? So about 24 miles high up. How far will it shoot? If halfway was 35, how far is it going to shoot?
Oh,
70.
About 70 miles out.
How'd you get 35?
We did the axis of symmetry. It's like 34.96 or something like that. Yeah.
I'm confused.
What do you got?
I don't got it. You did the negative b over 2a.
Yep.
Why is negative 1.7 divided by 2 times a really tiny decimal?
Because that's the opposite of b over 2a. That's the axis of symmetry of this really crummy quadratic function. So the opposite of b here, if we type that in.
Wait a minute. I think you already said.
Hmm?
Can you actually did you enter in your calculator? Put the fraction in there? Alright, so that fraction.
We substitute back in because that's your x coordinate.
I should be like 192.
So how does that fraction equal 34.96? Yeah. I put it. I said negative 1.37.
Opposite of b, negative 1.37 divided by 2 times negative 0.0196
is
34.95.
Hey, what? What did I do?
Let me show you. Once again, if I do a fraction bar, alpha y equals enter.
Oh.
Opposite of b, negative, because you're not doing order of operations right. That's why you're getting it wrong. Order of operations, you gotta group that denominator. You can't do. You probably did negative 1.37 divided by 2 times that.
I should put that in parentheses.
Yep. That's why I say use the fraction bar and you won't mess that up. So we wind up with 2, and then it would be negative 0.0196.
Here we go.
And there it is. Oh, I forgot the 0, sorry.
Wait, one more time, how do you get the fraction mark?
Alpha y equals.
Thank you.
You're welcome. Now it should work. Oh, I put it in the wrong side. Damn it.
Yeah, that's what I did, and I got the wrong answer too. That was good.
There you go.
Yeah.
Yes, ma'am.
Alright, on the line bottom, tab 35, where did you get the 4?
We took this as the axis of symmetry at 35. So all we do is you substitute in for x. And you're getting 24 and change in that neighborhood. And I'm just rounding it out just to kind of make numbers normal, just so you can kind of see how you can use the same idea of it's a parabola. When you shoot a cannon, it goes up and over.
Okay, so that's like, okay.
And that'd be the maximum height.
How'd you get this?
I doubled 35. Because if the axis of symmetry is the halfway point, and I'm starting at 0, I'm at 70. So basically what this means, if you were right here shooting straight east, you would land in Lake Michigan. It's only 66 miles to Navy Pier from here. So you're going to overshoot Navy Pier if you shoot the cannon from here. So you get the idea of how far that thing shot. Well, whatever, it's close enough. There's buildings in the way. Yes, ma'am. Substitute. Okay. I want you guys to work through as much of this packet as you possibly can. I think there's maybe a dozen problems in here. Some of them are a lot easier than others. A lot of it is just a matter of reading what it's looking for. You're looking to see if you're trying to find a maximum. You're looking to try and see if you're trying to find a minimum value and going from there.
Yeah, but
Gonna argue. Much better. It's getting there.
JC, he's also getting up.
Yes, it is. We're getting there. It's like, oh, I screwed up. I didn't look. What'd you do in math? We just chuck markers around, talk about maximums. What's up? You didn't have to. You could have. There's so many. or we could